Hello class, and welcome to section 1.7, Linear Models and Scatter Plots. Scatter plots and correlation. A relationship between two variables can be expressed as a collection of ordered pairs, as we know, x, y. The graph of such a set of ordered pairs is called a scatter plot. For a collection of ordered pairs, if y tends to increase as x increases, the collection has a positive correlation. Very much like what we would see when a line has a positive slope. We call this, though, a positive correlation. We don't yet have a definitive function to connect every single point. The points are scattered. If y decreases as x increases, the collection has a negative correlation, very much like a line with a negative slope. But again, we don't actually have a smooth curve connecting every single point. Example 1. The chart below gives the profit for a company for the years 1990 to 1999, where 0 corresponds to 1990, and the profit is in millions of dollars. So here are the years, 0 through 9, and here's the profit in millions, 5.1 to 6.77 for the range there. It says sketch a scatter plot of data. So what we're going to do to sketch our scatter plot here, we'll try to keep it as simple as possible. We'll make an XY axis, but really truncate the negative values because we don't want negative values for either the year or the profit. So we go ahead and we'll start, let's say, with 0, and this is years. And this is profit. Horizontal axis years, x-axis, and then the profit or y-axis is what we see there, the vertical axis. So let's go ahead and jump to 2 and 4, 6, 8, and 10. And as far as profit, we'll go up by 1s to 8. Well, 7 would probably suffice, but we'll say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1 to 8. And then simply just plot your points. So year 0 is at a profit of 5.1 here. Then we have year 1 at 5.22. $5.44, and so on. We continue plotting our points. As we continue, we can kind of see the trend. I would hope that, although maybe we can't necessarily connect all the points with one distinct line, we can see the trend that they do appear to be increasing from left to right. As x increases, y appears to be increasing. Very, very closely being possibly linear in nature. So that's the idea as far as a representation of the data using a scatter plot. Next, do the data seem to have a negative correlation, a positive correlation, or no correlation? Well, I think it's pretty clear here. Looking at the trend, as x increases, y does increase as well. Close to being linear in nature. We'll say that because y tends to increase as x increases, the data has a positive correlation. So y tends to increase as x increases. And therefore is a positive correlation. Next, fitting a line to data. In section 1.1, we learned how to fit a linear equation to two data points. In this section, we expand on this idea. Example 2. Find a linear model for the data given in example 1 above. So what we're going to do is we're going to pick 2 points. Somewhat arbitrary, but 2 points nonetheless. I'm going to pick 1, 5.22 and 6, 6.22. From here, we'll use what we are very familiar with, or at least should be at this point, and that is coming up with the point slope and maybe also the slope-intercept form. We'll go ahead and find the slope first. I'll take 6.22 minus 5.22 and divide that by 6 minus 1, which in turn yields 1 over 5. So we'll call that our slope. Now, is this the best slope? Not necessarily, but it is a positive slope. If I had picked another point or another 2 points altogether, I would have gotten probably, or likely at least, a different slope altogether. The slope is typically going to be within reason, close to 1/5, every slope. We'll stick to 1/5 because this is a best fit linear model that we're creating. So let's go ahead and use good old point slope form, y minus y1. I'll pick the first point, equals m times x minus x1. Now that's fine if I just asked you for point slope form, but if I asked you to simplify another step or two to get slope intercept, it would look something like this. And then we'd finish it off by adding 5.22 to both sides, which, if we do the math correctly, adding 5.22 to 1/5, which is also 2/10 or 0.2, we'll add that to get 5.02. This particular equation, as well as the original, I guess, point slope form here, could be different, of course, based upon the 2 points that you pick, but this is our linear model for the data given.